And let's welcome Lucian from Adeline. And if you are struggling implementing multilingual search and that to an e-commerce search, I think the next talk is going to be a delight for you, where Lucian is going to share his journey and some hurdles and challenges. And I'm sure we have a lot to learn from this talk. So let's welcome him with a big round of applause. That goes without saying.
Thank you, Atita. Okay, so hello everyone. Thanks for coming. It was such a great conference till now. Yeah, so we will talk about Apache Lucene. I think René also mentioned it in the keynote. 2022 was the year of vector search. We were talking about vector search everywhere. 2023 is the year of large language models. We talk only about that. So what will be in 2024? So my prediction is that it will be about Apache Lucene. Why is that? It's true that Apache Lucene has 22 years and counting. René mentioned 15 years plus, so it's actually 22, and Lucene became a top-level Apache project. It's exactly 22 years from now. And yeah, it's still there. We have a new logo. Yeah, I don't even know since when, but there's a new logo. And it happened, I mean, many things happened. So I don't know who uses Apache Lucene in one way or another, via OpenSearch, Elasticsearch, Solr, MongoDB. Yeah, okay. So what like struck me with Apache Lucene was things like this, and this is what tells you that it's a really powerful library and it's here to stay. So in 2011, there was this thing that about the Lucene fuzzy query being 100 times faster. It was a huge improvement. So it's the fuzziness that it's blocked now to 1, 2, or auto. So it's more restricted, but it's 100 times faster. So it's really huge. And then a lot of JVM bugs that were found by tests conducted on Apache Lucene. So Apache Lucene was actually finding bugs in the JVM. And yeah, so I also posted 2 tweets, which are from this year. And the last one is from Adrien from Elastic that talks about another performance improvement and what's coming next. We talk about a lot about Panama Vector API and all that. And I hope that 2031 we will see again Uwe Schindler at Berlin Buzzwords talking about what's next in Apache Lucene. I think he does that since 2016. So yeah, Apache Lucene. So you have a lot of search engines. I would say the best of them, or among the best of them, that are powered by Apache Lucene. You even have new ones like Atlas Search from MongoDB, which went for Apache Lucene also. And yeah, so just we started with Apache Lucene. A few words about me. I will work with Adilian, so we are search engine consultants. We are based in France, so you will see some examples from France and French, but I'll try also to, like, the purpose is to speak about all the European languages. So why this talk? Why do we need that? So first of all, it's not obvious to implement. Like it's not like something that's on the shelf there, and you just like activate a configuration and boom, Apache Lucene works for that language or that language. There are also a lot of languages in Europe. So if you have companies that want to like go widely, who's here from the United States or from the United States? Okay, we have people from there. So yeah, you have the advantage that the language is the same throughout all the like from east to west. Yeah, so we have also the United Nations of Europe, but the language is not the same at all. Yeah, so I'll try to give like tips, tricks, and all that. I'm not an expert, and I think people in this room are much better than me in German, in Polish or Czech or other languages. Yeah, I'm looking forward to have your feedback also. So this is like our journey in implementing that. So yeah, actually we didn't knew it was that complicated, so we want to share that with you. So we will share some tips and tricks there. Speaking about Europe, so I don't want to do politics, and I hope this is accurate. I don't want to enter in some conflicts there. So this is the first image that pops up when you search for European languages, and actually you have here the families of languages. So you have Latin languages, a lot. You have like German languages, you have Slavic languages, and yeah, some like Greek, which are alone, and all that. So you see, there are quite some differences there, and there are some structural differences. Okay, again, I'm not a linguist. It's not necessarily yeah, so my specialty. So it happens that sometimes, so we were lucky to have customers that have presence all over Europe. So this company, for example, is a French company, but it has websites, so e-commerce websites virtually everywhere. So you have to support virtually every language in the European, in Europe, actually. Or you might index names, family names. Even if you index just family names from your country, for example, France, or I think it's the same in any country in Europe, you might have names that are not really like natively French or natively German or all that. In France, for example, if you look at, so I have an example later, if you look at the French football team or something like that, you see names that are Arabic, Chinese, Polish, and all that. So you have like, even if your database is from one country, you might have things there. Or you might be crawling for the internet, for example, in this case, resources around Elasticsearch development, and you end up with English, French, Korean, whatever. Okay, so Korean is not European, but you see the point. Okay, so back to Lucene. Now, there's one thing that you need to know about Lucene, and you might not know this. Lucene works with keywords. Is the network still there? I hope so. And what we call an inverted index. So it's really important to understand how this works in order to understand all the problems that you get out of this. So in this example, I have two documents, and you see the analysis chain that happens, and this is like standard with Lucene. That happens at index time, at search time. In this example, I have a filter that's called ASCII folding that will suppress accents that are there in French. In German, you have something different that's called yeah, I forgot the name, but it replaces like German letters with a double S or stuff like that, or yeah, similar to ASCII folding. And then you have lowercase, which is another filter. And down there you have what's in the Lucene index. So in this example, in the Lucene index, you lost the capitals and you lost the accents. And the same happens at search time. When you search, the same analysis chain is executed, and actually when you search for this text, you will be searching for that one because you have ASCII folding and lowercase. Here's an example from in English. And we also introduced something else, which is called a stemmer. And the stemmer allows you to put into the same key, into the same Lucene key, the words that have the same root. So in this case, developer, develops, and all that. Okay, and you notice that the stemmer, so it depends which stemmer you use and all that, will actually generate words that are not real words. So for software, for example, we have the E that disappeared, and yeah, so on. So yeah, I hope this part is clear. And you have in search engines that are built on top of Lucene, you have APIs that help you understand how your text was indexed. Okay, so for example, this is a screenshot from Kibana, but we can do it directly here. So for example, this is the API, and when I run it, I said I'm a developer in Berlin. Oh, sorry, the network. Okay. So notice here the text and the analysis chain that I have here. So I have a lowercase, I have a stop filter that will remove stop words from the English dictionary. And then I have an English stemmer. So I run this. So you see that the text that is actually indexed will be this one. So I don't have capitals. Developer fall back to develop, and I have lost the stop words. Okay, so the same with those ones. And if you want to see the details of what happened there, you say explain, which is true. And it tells you step by step what happened with the text. Okay, so this is very powerful, and it's available in a Elasticsearch. It's available in OpenSearch, and in Solr you even have a graphical interface for that, which looks like this, that tells you what happened with your text when you. So you can even compare index and search time. Yes. So the analysis API. Now, okay, so Lucene is very powerful, and actually you also already have language analyzers, and you have these analyzers that are there. So this screenshot is taken from OpenSearch, just to be fair with all the Lucene implementations. And you see, you have kind of all the languages that you need. So why is this that complex? So actually, it's not that simple. So let's take, for example, the stemming, which is included in all these language analyzers. So stemming is preferred by those that implement Lucene, that build solution on top of Lucene, because it's supposedly faster and it can be shipped out of the box. Is an algorithmical approach to like create a reduced form of words. So for example, these are in French. It means developer in a masculine form and developer in the feminine form. And you see that the stemming will reduce this to this thing here, which is not a real word, but it's an algorithmical approach. Okay, so the truth is that it's not necessarily faster, the stemming, but it depends on your implementation, as we will see. But yeah, the lemmatization, which is the alternative, which is better, cannot be shipped like this because you have license issues and all that. So the stemming is not perfect. Why is that? Because it's algorithmical, it doesn't know words by dictionary, and it can lead to things like that, which in e-commerce is really bad. So these are taken from French, but I'm sure you can find that all over Europe. So for example, when you search for the Gillette brand, actually that stems into something that means jacket in French. When you search for Barbie, you know, the baby doll, the doll for babies, for babies, for kids, you actually end up with the same stemming as beard. So yeah, it's really, these screenshots are taken from some development versions that we did. And yeah, you had this thing like that. And then you have the other way around. You have the stemmer that doesn't correctly stem the singular and the plural. In this case, you have work and works, which are not correctly stemmed because the rule is like that. And you might have things like irregular words, like similar spelling, like broker, broken, stuff like that. So not really the solution. Like if I look at the details now of what's behind this shortcut, like analyzer and just one language, this one is given for German. So you see the detail of the German analyzer in OpenSearch and Solr and Elasticsearch. And it looks like that. So you can see the stemmer there. You can see something, we see something that's keywords, and it's the key to our improvement. And you see also the stop words. Now, if I look at the keywords, so these are the levers that I have in Lucene to like tune the stemming. The keyword marker is very important because it allows me to protect some words. And usually in e-commerce, we protect all the brand names. It allows us to avoid things like we have seen. So how does it work? This is without the protected words. So you see that I'm using this analyze API, and I see Barbie and Beerb that stem to the same thing, and so on. And you even have cross and croissant that stem to the same thing. Okay. So if you're looking for food, for example, for croissant, you can get like this is Lacroix is a brand for like for housekeeping. Okay, so when we add the keyword marker here, like we protected these words. So ideally we put there all the brands, or at least some of the brands. We see that the stemming is different. Barbie stays there like that. Gillette stays there like that, and so on. Now the other one, stemmer override, is the other way around. I will tell the stemmer to do something different. It was like the example with work and works. So you do the custom stems and you override the stemmer and you place there a list like that. Now you imagine this works. The problem that we have is that you have to provide the list. Actually, you have to so you have to have the business people that provide you the list of protected words, the list of stemmer override. You will not find that in a dictionary or something like that, and it's something that's specific to your business. Okay, how about the other way of stemming, which is dictionary stemmers? So again, Elastic says that they typically not perform well. They suggest that you should use algorithmic stemmers, but yeah, sometimes they help. We actually used this for a large e-commerce website in France, and we used lemmatization. And why it worked because if you look at the disclaimer that Elastic places in the documentation, it actually so the dictionary stemmer performs bad if your dictionary is bad. But the key there is to have your own dictionary, okay? If you have your own dictionary, it is small, you don't have license issues, and is also adapted to your business rules, okay? So we actually use lemmatization to avoid all the things that you have seen with the croissant and cross and Barbie and Beerb and all that. And it's much, much better. Okay, but yeah, be careful about the license and also performance. Okay, next point that I wanted to bring up is the stop words. So again, I'm giving here all the journey that we had, and this is like a recipe that you can take and implement in your environment. So you have something that's called stop words and a filter in Elastic and in OpenSearch and in Solr, but we actually do not use that. The reason we do not use that is actually advertised there in this Jira issue, which is still open. So I've taken this from a presentation that I did like 1 year or 2 years ago, I don't know. And this Jira issue is still open. I verified this morning, and it's still there. And it's actually, we give a detailed presentation of that in this talk. But the bottom line is that we don't use the filters that are available with Lucene. We actually use this thing to remove the stop words. Okay, and yeah, why we need to remove the stop words? This is another point there. And actually, we don't remove all the stop words that are in the dictionary. Okay, this list here is a list that the business people will give, and in your case, it might be different. If you're indexing names, these tokens here are important for names. I don't know. In France, you have names like that, which is something de la something. So it's part of the name. You don't remove that. But yeah, okay. So stop words that just a caveat and a hack here to use those. Again, we do that because of this bug here that doesn't allow you to use stop words with synonyms or with a word delimiter graph. Okay, now another issue that you might run into when you search for when you like implement Lucene for languages is like detecting the most important word in a phrase. Why is that important? That's important because so imagine this case here. You have oranges, which are specifically oranges that you use to make orange juice, and then orange juice, okay, which in French is like 3 words each, and they just have switched places. Now, if you look in this index for orange, just oranges, you actually mean the fruit. But from Lucien's point of view, the orange juice is just as relevant. So you might end up with orange juice when you search for the fruit for just one word, oranges. Okay, I will not enter into the details of this, but anyhow, I placed here a demo. We will not do it. You just have the screenshot. It's kind of small, but in general, I mean, what it says is that so I'm searching for oranges, and actually I have oranges in the first position and not this thing, which is the best result. So how do we solve this? This is a screenshot from Algolia. I've seen that there are people from Algolia. Actually, Algolia has an option in their business console that's specifically for that. That's called ordered, and says, okay, the most important term is in the beginning of the text. So actually, yeah, that works. In Lucene, there's nothing like that, but we can implement that. And we actually did implement that. This is our business console. And you have here this thing that's called en tête, which means first word. And you can say first 1, first 2, first 3, and so on. And it works like this. So if you notice, so this is the Lucene query explained. Okay, so this one here in the middle. And you see that we have a match in functional name dot value dot first, which is the analyzer that I mentioned previously. Okay, so yeah, pretty straightforward to implement. So not available off the shelf in Lucene, but you can implement it yourself. Problem solved, but only for Latin languages. So I guess, yeah, I don't know what's the story with that in Algolia, but I guess Algolia implemented that because in French, and Algolia are French also, in French, this is valid. The first word is usually the most important, but this is not true for English, for example, and it's true for Czech either. So we said, okay, we cannot implement that like that. Let's come with something else. So with our Czech colleagues, we kind of found this rule here, which says the accent is on the second word, except you have a particle there, like in this case for iPhone, which is the first word. And in the case you have a particle, the accent is on the word right before the particle. Okay, so this is because we just didn't want to use machine learning and all that. We are in 2024, so it's the year of Apache Lucene. Okay, so the example there is in Czech. So you see that Czech is kind of similar to English because you have the same thing. You have a, I don't know how this is pronounced. I'm not an expert again, but you have the same thing. You have the particle, which means for, and in this case is the word before, and you can also have the other way around and so on. Okay, so problem solved. We have found this algorithm and we can go on. Okay, the only thing to know about this is that when you do this, even this one, you have the, and I'm talking about the business console here, you have to have business people that provide you with lists. They provide you with keyword markers, with stemmer override, with particles for Czech, for English, for now all the languages. So you need this thing here, the business console, that is a window to the business people, so they can configure Apache Lucene on their side with these lists there. Okay, so yeah, the business people can have that. So you have this config console that helps for that. This is a screenshot from a config console that we built specifically for the website that I was mentioning that has subsidiaries all over Europe, and you can see here on the left list of synonyms, list of stop words, list of protected words, and this was not finished at the time when I took the screenshot, but you have also so protected words is keyword marker, and you have also particles for all the languages. Now, eventually, we end up with NLP, because if you have queries like this one, I want to buy an iPhone case, which is the most important word there. What am I searching for? I'm searching for an iPhone. I'm searching for something else. Which is the word that means what am I looking for here? And the same for like this one, which is more complex. I want to buy a small orange Apple iPhone case. Okay, so the algorithm that I mentioned earlier doesn't work. So eventually we ended up using machine learning, and there's this tool that's called Apache NLP that's really great. And I wanted, I don't know if, can somebody tell me how much time do we have? 5 minutes? Okay, well, okay. Okay, I just wanted to show you how this is implemented, so you can just take that home. So very quickly, so actually OpenNLP, you can easily train some models there with your data, and you just need 15,000 phrases to train it correctly. But actually, these examples that I showed you worked with less than that, and so they are here, so they work, except for this one with orange. It was made on purpose because I have orange Apple iPhone case, and orange is also a noun, so yeah, it was an ambiguity there. And just I wanted to show you the how we trained the off-the-shelf models just to be able to do that. So you have just 15 lines here. So we don't talk about iPhone or stuff like that. We talk about Samsung and stuff. So just to make sure that we didn't provide the model with the exact answer. And it works. We just provided 15 lines and not 15,000. And it kind of worked for these simple examples that I gave here. Okay, so let's move on. Okay, so we finished with that. We have managed everything. When actually it's not that simple. We have some languages in Europe that do their way. So when you look at the Elastic documentation, they say whenever you can use algorithmic stemmers. Okay, we did that. We configured them. We have given all the configuration that needs so they work correctly and all that. But it happens that with Hungarian is not true. And why is that? Because there's this handspell, and if you look at the documentation for handspell in the Elastic documentation and OpenSearch also, I guess, they say don't use handspell if you can use the algorithmic stemmers. But handspell was built by Hungarian university, and it was initially and specifically built for Hungarian, and actually nothing else like took over, and you really should use handspell for Hungarian. Now you say, okay, we solved the problem for Hungarian. You can find dictionaries which are open source kind of, because you have LibreOffice, you have Mozilla that have dictionaries for Hungarian, so you can take them, so your dictionary stemming works correctly. And we say, okay, problem solved. How about Finnish? So it turns, is there someone from Finland here? No. So Finnish, it's actually a language. I don't know if you have saw on the map I showed in the first place. Finnish is a language that is the same family as Hungarian. So you would expect that if handspell works for Hungarian, Finnish should also work. It's not true. It does not work. They have also some German influences, and this is a word that's it's really a real word. You can find it in Wikipedia. And it's a Finnish word, okay? And yeah, so handspell doesn't work. So you have different implementations. Yeah, so those from Finland will know better. You have this one, Voiko, which was overridden by Rodiko, that one. And it has things like this. So you can see here you have a split compound words parameter that you can set to true. So it will split compound words and so on. Okay, I will move faster because I don't know, we still have 1 minute maybe, or no. Okay, so really quick, when you index names, you should take care about the phonetic analyzers that is available out there. Don't use it. This is an example from French. Mouton means sheep in France. So actually the name Madonna and the noun mouton actually go to the same phonetic representation, so you don't want that. What we did, so I don't get into details here, but we did like a phonetic with these. You can find this in Berlin buzzwords with ARPABET and IPA, which are dictionaries that are available, and standards for encoding. This one you have seen it in school maybe when you learn foreign languages. Okay, so and last example, I will skip the demo actually because I have a demo for this, or yeah, maybe, which is compound words. The point here is, well, this is too complex. I will show you just the demo very quickly, just to see the result. I will not be able to tell you how it's implemented, but I'll just try here. So you know the compound words that are like what's the word? Joined together, yeah. So actually you have this problem in Finnish, in German, and you can also have it in French if people do mistakes when they type. So for example, here, somebody wanted to say cherry tomato, and they said cherry tomato in one word. And does it work? Actually, it does not work. You will find 0 results. And actually, there are many steps to implement that. But the idea, really main idea here is that, okay, we find 0 results. We say that's not good for e-commerce. Let's try something else. Let's try fuzziness. Okay, we try fuzziness. That does not work because it's too far away from any other word. We try OR operator. That does not work either. And then we end up with this fallback mechanism, which is some specific mechanism that we implemented in our search engine that gives you actually results. We have 38 results here, which actually are tomatoes like that. And so I searched for this word and I found this word. So it's actually based on a fallback mechanism based on suggestions. And here are the suggestions. So you see the text that's the suggestions that are indexed. So you have this one. You have other variations like this one, which doesn't mean anything, but it's not a problem because you have occurrences here that will solve the problem later. And like for this one, for example, also 3 words. So you have combinations like that that will actually be helpful in order to solve this thing here. And we use this even for French, even though it's a problem mostly in Finnish and German and in the Netherlands with Flamand. Yeah. So I think that's it. So thank you, and I hope we have fun.
Okay, so I guess we are running short on time, but we can definitely take. So we have one question online.
Okay.
You expose configuration for business for these stop words, etc. I wonder if they realize how it works, because it's very specific linguistic knowledge. For example, if you have a case for iPhone, it's good, but case of paper, it's a different story. So if they just add all prepositions into this dictionary, they can retrieve not expected results.
Yes. So the training that we do for business people and what we tell them is that they should really not add anything without, like, I mean, they should be minimalistic in that. So for stop words, for example, the list is kind of very small. Okay. So the idea is to be minimalistic, and they add words when there is a use case that's like they have seen that it does not work. So they see that there's a result that's not working. They improve the list. They see that it corrected the result. We also have mechanism to test for the non-regression of the relevancy, and they do that like that. And stop words actually doesn't move. So we just need the stop words for different languages. So the list is really small, and the idea because we opened that for Czech and for other languages because we just don't know how they are written and all that. And for keyword markers is the same. We say, okay, you have to be minimalistic and just place their brands and words that you know that they are problematic. Okay. And you can also give to the business people the Analyze API. They can easily understand how it works, and they can see that that text is indexed like this, and they understand very quickly. So, yeah.
Thank you.
But it's not like you just give them the the interface and you say, okay, do whatever you want with that. Yeah.
Okay, looks like we have 2 questions online, but I'm going to take the first one. Do you have any advice for dealing with widespread dialect in search? For example, Swiss German has many variations of the same standard German word.
Yeah. You even have like regional languages, even in French. So, and you don't necessarily have like top level Lucene stemmers for that. So it depends. Yeah, sometimes you need to implement them yourselves. So for example, for French names, the phonetic off-the-shelf filter does not work. We actually implemented one, which is like, yeah, you have to develop a plugin and you say, okay, I'm using like we said here, the ARPABET or the IPA, and you just transform your text like that. So yeah, hopefully you have like associations, universities that can give you some hints. You have dictionaries that help you like construct a plugin for your language.
Okay, I think there is another second question which is latched onto this question. That could you further elaborate on the solution for the compound words, specifically n-gram suggestions used and generated? Since you did not have sufficient time in the presentation, any extra information you have is welcome.
Yes.
I guess maybe you can answer it here or maybe on the chat.
we can answer in the chat, and maybe yeah, we can also try to do a talk
relevant
tomorrow, a lightning talk tomorrow on that.
Sure.
If, yeah, I think it deserves to be explained.
Okay. So
More.
I guess so Sven asked this question, and I think he
Yeah,
would
it's
definitely
actually you have 3 steps, and they are all important, and they all have their own explanation and all that. But this is the recipe actually.
Cool.
Yeah.
Fair enough. And I guess we definitely have a lot to ponder upon. And thank you so much for sharing this information with us. So let's thank Lucian with a big round of applause.
Thank you.